Hi, I'm Professor Kaplan, Charles Kaplan. I'm retired. I taught economics and applied math for about 20 years at the undergraduate and graduate levels right here in New York. I am putting up these videos to help everybody. Um, you can also use me as a private tutor. I'm also available as a private tutor through the Wyzant website. You can find me up there, Charles Kaplan, Kaplan. And let's see, this video is on simplifying algebraic functions. We're going to start very easy with very basic, simple problems, and then we'll work up to more difficult problems. And I think this is probably going to go on at least two videos. It'll probably might continue for a third video. We'll see what happens, but I'm sure it'll take up two videos. Okay, so let's get started. This really isn't even an algebraic formula, but we could do 4 over 12. And if we do that, 4 is going to go into itself one time, and it's going to go into 12 three times. And so 4 twelfths reduces to 1/3. Okay? So we're going to be doing, that's essentially what we're going to be doing for all of these fractions as we go along. It isn't any more difficult than what we just did with 4 twelfths. So, and here's what I mean. We have 6x over 16y. Now, x and y, they don't go into each other, so there's nothing we can do there. But we can reduce the 6 and the 16 part. So, for example, 6 is 3 times 2 times, well, 6x is 3 times 2 times x. And 16 is 8 times 2 times y, 16y. So the 2's can cancel, and we're left with 3x over 8y. Not hard. This is not hard. This is simple, basic stuff, okay? You should be able to catch on to this really fast, really easily. All right, so you see what I did here? I found a common factor between them, the greatest common factor, actually, because if we broke 6, the prime factorization is 3 times 2. 16, the prime factorization, well, let's see, 8 is 2 cubed, so it's 2 times 2 times 2 times 2. 16 is 2 to the 4th. And this is 3 times 2. If you want, we can put in the exponents. So the only thing we're going to be able to do here is cancel out one of the exponents and make it 2 cubed in the denominator. So not a lot we could do with that one, but nevertheless, it's a pretty easy problem. And I suggest if you do have trouble with one of these problems, you stop the video, pause it, go back, rewatch it, and so forth. You'll get a lot out of it. All right, next one, we have 9xy divided by 24x. So on this one, the x's go out. They cancel each other out. And we're left with 9 over 24. Well, 9 is 3 times 3, and 24 is 8 times 3. So we can get the 3's to cancel there, and that leaves us with a 3 over 8. So this is going to be equal to 3y over 8. Okay, you see what we did there? 9, 3 times 3, 24, 8 times 3. The 3's go out. That leaves us with an extra 3 in the numerator and an 8 in the denominator. Okay. Let's see what the next one is. 12y over 20 xy. So again, the y's cancel, and the 12, well, the 12 is 4 times 3, right? And 20 is 4 times 5. So the 4's can cancel, and that's going to leave us with 3 over 5x. Remember, we still had that x here that didn't cancel with anything. So what we did was we got a greatest common factor here, 4. So 4 goes into 12 3 times, it goes into 25 times. So we're left with 3 over 5x. All right, the next one is negative 15x squared y over 25x. Let's make this 25x y squared. We'll change it up just a bit. So let's take a look at some of the rules of exponents here. So if we have a to the x times a to the y, we have a to the x plus y. If we have a to the x divided by a to the y, we have a to the x minus y. And so that's what we have going on up here. Now, let's deal first with the 15 and the 25. We can see easily on this that 5 is the greatest common factor, and 5 goes into negative 15 negative 3 times. And 5 goes into 25 5 times. So we just took care of the numbers. Now, let's take care of the x's and y's. This is x squared over x, which is x to the 2 minus 1. Remember, there's an implied exponent of 1 there, which is x to the 1. So that's going to leave us with an x in the numerator. And then we have y to the 1 over y squared, which is y to the 1 minus 2, which is y to the negative 1. And when we get a negative exponent, that just says, hey, kick me down into the denominator. So y to the negative 1 is 1 over y to the 1, which is 1 over y. All right, remember, negative exponent just says, put me in the denominator. So this is going to give us a y in the denominator, and we could see that because if we put in the little 1 here, y goes into itself if y is the greatest common factor here. If we put the little 1 up in here, y goes into itself 1 time, and y goes into y squared 1y times. So we're left with negative 3x over 5y on this one. All right, let me just go back over that. That's a little bit more difficult than what we did in the prior few examples. So let's start a new page here. Let me put this problem up once more. Negative 15 x squared y over 25 xy squared. We dealt first with the 15 and the 25, and we got 5 is the greatest common factor, so negative 3 and 5. 5 goes into negative 15 negative 3 times. It goes into 25 5 times. So that's the easy part. So now we have x squared over x. So x goes into itself down here one time, and it goes into itself up here x times, x to the 1 times. So we have negative 3x. Now we have y up in the numerator, and remember there's an unwritten 1 as an exponent there. So y goes into itself one time, and it goes into y squared y times, because y times y equals y squared. All right? Or you can look at it this way, y times y, and we have the implied 1s for the exponents, is y to the 1 plus 1, which is y squared. So negative 3x over 5y. Okay, let's move on. Okay, here we have 16 x cubed y squared over 28 x squared y. And, I suggest after I write the problem, pause your computer, try doing the problem on your own, and then turn it back on and see if what you did is what I did. That's a great way to handle these problems. So, okay, so we need to find the greatest common factor between 16 and 28. It turns out that, well, that's 4. 4 times 4 is 16, and 4 times 7 is 28. So 4 goes into 16 4 times, and it goes into 28 7 times. So we're going to have a 4 in the numerator and a 7. That didn't look so great. A 7 in the denominator. Now we have x cubed over x squared. And remember, x cubed over x squared is x to the 3 minus 2, which is x to the 1. So we wind up with an x here. And then we have y squared over y over here. And y squared over y is y to the 2 minus 1, which is y to the 1, which is y. So we're going to wind up with a y over here. So if we want to clean this up a little bit, and we want to write this a little bit neater, we can do 4xy over 7. 4xy over 7 right there. Okay. Let's move on. Negative 36 x to the 4th y cubed over negative 48 x to the 6th y squared. Now, you should be able to determine the greatest common factor here. That one I think is pretty easy. 12 goes into 36 3 times, and it goes into 48 4 times. So 12 goes into negative 36 negative 3 times, and 12 goes into negative 48 negative 4 times. We could have factored out a negative 12. That would have made it a little bit easier, I think. But let's just stick with the 12 for now. So that leaves us with a negative 3 in the numerator and a negative 4 in the denominator. Now, x to the 4th divided by x to the 6th, that's x to the 4 minus 6 x to the fourth over x to the sixth is x to the 4 minus 6, which is x to the negative 2, which says, hey, put me in the denominator. And that's exactly what we're going to do. We're going to make this x squared. And then we have y cubed over y squared. Well, the greatest common factor here is y squared. Y squared goes into itself one time, and it goes into y cubed y times, because y squared times y is equal to y to the 2 plus 1, which is y cubed, which is what we started with over here. So we're going to put a y right here. And because we have a negative over a negative, we wind up with 3y over 4x squared. And that's our final answer. Now, let's take a look at the next problem. 18x cubed y over 36 x y cubed. And by the way, a lot of students often think, why do I have to learn this? I am never going to learn this. I'm never going to need this when I go to work. I'm going to be a police officer. I'm going to be a fireman. I'm going to be a sales rep. I'm going to be whatever you're going to be. You're probably not going to need to reduce, simplify algebraic fractions like this. And you know what? You're probably right. But you're going to take higher level math classes. And for example, if you want to take calculus, calculus is the easiest form of math there is. There's nothing easier. I know that students often think that calculus is such a hard subject because you use all those Greek letters in it, but it's not. It's actually quite easy. The rules of calculus are incredibly easy. What makes calculus difficult is the algebraic workouts. This kind of stuff. So if you want to go on and do a little bit higher level math, you need to be able to do this. You want to do economics, you need to be able to do this. Which means even if you want to be a business major in college, you're still going to have to take macro and micro, and especially with micro, you're going to have to be able to do stuff like this. It's important. So learn it now when it's easy to learn it. Also, here's the other reason we learn how to do math. It mimics real life. Now, here's what I mean. In real life, when you're faced with a problem, in order to solve that problem, you have to lay out a plan. And you have to, as part of that plan, you're going to have multiple steps to reach your goal, the solution to the problem, whatever that is. And you're going to need to follow multiple steps to achieve your aims. Well, that's exactly what you do in math. You follow a predetermined set of rules or steps in order to solve a problem. This is training you for real life. Follow the steps, you arrive at a correct solution. Just like in real life. You have a problem, create a plan, follow those steps, solve your problem. Okay, let's get back to more mundane things such as 18x cubed y over 36xy cubed. Well, I think by now most of you realize that 18 times 2 is 36, so 18 is the greatest common factor here. So 18 goes into itself once and into 36 twice. So we're starting off with a 2 in the denominator. Now, x cubed over x, well, x goes into itself once and into x cubed, x squared times. So we're going to have an x squared up here. And y goes into itself once and into y cubed 2 times. So we're going to have a y squared down here. And that is the answer to this particular problem. X squared over 2y squared. I'll show you that one again. 18 x cubed y over 36 xy cubed. The 18 and the 36, that's easy enough, 1 over 2. And then x cubed over x is x to the 3 minus 1, which is x squared. That goes up here. And y over y cubed is y to the 1 minus 3, which is y to the negative 2, which is, hey, kick me into the denominator as 1 over y squared. And that's exactly what we're going to do. We're going to put the y squared down in the denominator. So there's our solution to this problem. Let's move on. Okay. All right, we've got 12 x squared y to the 5th over 54 x squared y cubed. Well, let's see here. Six is going to be the greatest common factor, so 6 goes into 12 2 times and into 54 9 times. So we're going to have a 2 here and a 9 down here. Now x squared over x squared, that just goes out. X squared divided by x squared is 1. And that leaves us with y to the 5th over y to the 3rd. Well, y to the 3rd is going to be the greatest common factor here. And so y to the 3rd goes into itself, sorry about that, 1 time. And it goes into y to the 5th, y squared times. So the answer here is 2y squared over 9. Let me just show you the y part alone on this one. We have y to the 5th over y cubed, which is y to the 5 minus 3, which is y squared. And that's what we had up here. Okay? Next up on our hit parade. 24 x cubed y cubed over 39 x to the 5th y squared. Well, 39 is 13 times 3, and 24 is 3 times 8. So this is a prime factorization right here on 39, 13 times 3. So 3 is going to be the greatest common factor here. So 3 goes into 24 8 times and into 39 13 times. So we're going to have an 8 and a 13. X cubed over x to the 5th is x to the 3 minus 5, which is x to the negative 2, which says, hey, put me in the denominator. Or we could say x cubed is the greatest common factor. It goes into itself once and into x to the fifth, x squared times. And y cubed over y squared is y to the 3 minus 2, which is y to the 1. And there we go. So this goes into itself once and into y cubed y times. So our answer is 8y over 13x squared. And it looks like we have enough room on this page to do one more problem. 32 xy squared z cubed over 72 y z to the fourth. Notice that when I write a z, I write a z with the little bar going across the middle, and that's so that it doesn't get confused with the number 2, which is easy enough to happen. And you should get into that habit of writing a z this way. I've seen a lot of students make mistakes on exams and on homework when they thought they were writing a z. They went back, they looked at it, they thought and they said, oh, it's a 2, and they wrote in 2 instead of z. And then what invariably happens is they come up to you after you hand back the papers and they say, oh, professor, this was really a z, not a 2. I made a mistake when I copied it. Makes it a pain in the neck for the professor and for the student. Just FYI, I would always give them credit for it if they came back and they said something. I was a nice guy. Okay. 3272. Well, looks like 4 is going to be the greatest common factor here. So 4 goes into 32 8 times. It goes into 72 18 times. Look at that. That's not going to be the GCF. Let's work on this a little bit. 32 is 8 times 4. Oh, right, which is 2 cubed is 8, 16. 2 to the fifth. 2 to the fifth. And 72 is 36 times 2. And 36 is, 9 times 4. So we have 3 times 3 times 2 times 2 times 2. Right, so that's 9 times 8 is 72. So let's see, we have 3 squared times 2 cubed. So 8 is going to be the GCF. So 8 goes into 32 4 times, and 8 goes into 72 9 times, right? We got that down here and over here, 9 times 8. So that's what happens on this. Sometimes you just have to play around with it a little bit when you're looking for a greatest common factor. Sometimes you make a mistake. I caught that one when I saw 8 over 18 and realized that we could have reduced it down from there to 4 over 9. So we have 4 in the numerator. We have x in the numerator because we don't have any x corresponding with the x in the numerator and the denominator. We have 9 in the denominator. And then we have y squared over y. Well, y goes into itself once and into y squared y times, so we wind up with a y here. And then z cubed over z to the fourth is z to the 3 minus 4, which is z to the negative 1, which is 1 over z. So we're going to put that z down here. So there's our solution, 4xy over 9z. Okay, now if, by the way, let me just come up over here. If we wound up with 8 over 18, which is what originally was going to happen, I saw that 2 goes into 8 4 times and into 18 9 times. So we still would have wound up with the same thing over here. Just would have taken us a little bit longer to get there. Okay, how about 27 x squared y cubed z to the fourth over 45 x cubed y cubed z. So here, 9 is obviously the greatest common factor. 9 times 3 is 27, and 9 times 5 is 45. So 3 and a 5. So we're going to wind up with 3 here, 5 here. X cubed over x squared over x cubed is x to the 2 minus 3, which is x to the negative 1, which is 1 over x. So we're going to wind up with x here. Right? We have x squared over x cubed, which is x to the 2 minus 3, or x to the 2 minus, well, x to the negative 1, which is 1 over x. So we're putting this in the denominator. And then we have z to the fourth over z, which is z cubed, right? Z goes into itself once, and it goes into z to the fourth, z to the third times. And there's our solution to this one. Now we're going to change it up a little bit. And we're going to have to do a little factoring now. So I'm going to do a couple of those problems, and then I'll leave the remainder to a second video on simplifying algebraic fractions. So let's do the next two. So we have xy over x squared minus 2x. Well, we need to factor the denominator, and if we factor that, we can take out an x, right? X to the 1 is the greatest common factor between these two. So we have x times, well, x minus 2. And if we were to distribute the x back, x times x is x squared, which we have over here. And x times negative 2 is negative 2x, which we have over here, over x times y. And now we can clearly see that this x and this x cancel, and that leaves us with y over x minus 2. Looked a little harder than it was at first, but once you realize that you have to factor out this x over here, it becomes a very simple problem. Let's do another. X squared plus 5. X squared plus 5x, sorry, over xy. And again here we're going to, only this time in the numerator, we're going to factor out an x. we get x times x plus 5 over xy. All right, if you see that x times x is x squared, x times 5 is 5x, so we're good there. So now we have a cancellation here and here, and we're left with x plus 5 over y. And there's our solution to this one. Let's do one more here. So we've got 8x plus 12y over 12. So in the numerator, the greatest common factor that we've got there is a 4. We can't do anything with the x and the y. So we get 4 times 2x plus 3y, and 12 is 4 times 3. And just to double check, 4 times 2x is 8x, and 4 times 3y is 12y, and 4 times 3 is 12. So here we see that the 4's cancel, and we're left with, put it down here, 2x plus 3y over 3. And that's our final answer here. In case you're wondering, can you reduce here? No, you can't. No reason to do it, first of all. I mean, technically you could do 2/3 x plus y, but why make it more difficult like that? So just leave it like that. That's the way to do this particular problem. So we're going to leave it there. Once again, I'm Charles Kaplan, Professor Kaplan, retired. Taught economics and applied math for about 20 years at the undergraduate and graduate levels here in New York. And I'm putting up these videos to help students around the world, actually. And if you'd like private tutoring, you can reach me through the Wyzant, W-Y-Z-A-N-T, through the Wyzant website, Charles Kaplan, K-A-P-L-A-N. Okie doke. I'll be seeing you in the next video. We have a part 2 to this video, and I'm sure at least a part 3 now, because I have a lot of problems here ready to work out. So check out the second video in this series on simplifying algebraic fractions. Okay.